Ayan. So, dito naman tayo sa susunod na topic natin. The second configuration na merong negative feedback. Okay? This is the voltage follower. So, itong voltage follower, ang kagandahan nito is that wala tayong resistor elements nagkagamitin. So, yung ating feedback, kung ano yung output, ibabalik natin siya agad dun sa inverting inverting pins ng ating op amps. So, with this, anong nangyari? Nagka-cancel lang yung ating uh, nagka-cancel lang yung attenuation tsaka gain. Kaya mangyayari, yung voltage, yung feedback voltage natin which is equal to the voltage output, so yun yung mismong ibinabalik na natin sa ating circuit, equal na yan, di ba? And of course, yung dahil dyan, uh, yung ating attenuation will be equal to 1 and yung ating closed loop voltage gain is also equal to 1. Ibig sabihin, kung ano lang yung pumasok, yun din yung lumabas with the same amplification. And then yung ating voltage output is equal dun sa ating voltage input. Kaya tinatawag na siya na voltage follower. Kasi wala talaga siyang amplification na gagawin. Kundi kokopyahin lang niya or ifa-follow lang niya kung ano yung voltage dun sa input. So itong voltage follower usually ginagamit natin 'yan sa mga buffer amplifier na ginagamit for interfacing yung mga high impedance sources sa low impedance loads. Ito yung ginagamit. Okay? So, tingnan natin kung ano yung uh, sample problem, kung anong meron dito, kung bakit kailangan natin siya pag-aralan. Bago yon, yung formula muna ng mga input impedance and output impedance. Katulad ng the input impedance ng isang voltage follower circuit amplifier is equal to 1 plus open loop voltage gain. Dapat meron niyang V, di ba? Pero dahil equal lang naman sa 1, so kahit wala na, hindi na natin isulat. Times the uh, dito, input impedance ng ating open loop na amplifier. Okay? Then sa output impedance naman ng isang voltage follower, it is equal to output impedance ng op-amp divided by 1 plus open loop voltage gain times yung ating attenuation which is equal to 1, kaya hindi na natin isusulat yan. No? So, halos pares lang din yung mga formulas. Except that yung ating beta, equal yan sa 1. Okay? So, let's try to solve an example on this. Yan. So, we have here a voltage follower circuit. We are to find the input and output impedances of the voltage follower in this particular figure. So yung amp na ginamit dyan, meron siyang Z-sub in or input impedance, tapos meron din siyang output impedance, no? Yan. Kaya, given sa atin, Z-sub in equal yan sa 2 mega ohm. We also have the output impedance equal yan sa 75 ohms. Then we also have this voltage, open loop voltage gain equal to 200,000. No? And we are to find the input impedance kapag voltage follower na siya na circuit, and yung ating output impedance kung naka-voltage follower circuit na yung ating op-amp. No? So, ang solution natin dyan is that meron tayong formulas, no, na gagamitin. Yung C sub in or yung input impedance ng ating voltage follower equal yan sa quantity 1 plus A sub OL at times attenuation which is equal to 1 lang naman times ng ating Z sub in. Ayan. So, substitute lang natin yung mga values. 1 plus 200,000, di ba? Times, Z sub in natin is equal to 2 mega ohms. Therefore, yung ating voltage follower circuit will now become is the value using your calculators. It is now equal to almost 400 giga ohms. So ano ang nangyari dito? Nung kinabit natin yung amplifier or yung op-amp uh, into a voltage follower circuit, from 2 mega ohm, ang nangyari sa ating input impedance, it went high as 400 giga ohms. So napakaganda nito, no, dahil halos infinite, no, almost infinite na yung ating input impedance, which makes this circuit very or ideal sa mga interfacing or buffer amplifier interfacing yung mga high impedance sources doon sa mga low impedance loads. So, punta naman tayo dun sa isa, yung ating output impedance ng voltage follower. Ang formula lang natin dyan is C sub out or output impedance ng ating op-amp divided by 1 plus A sub OL. B, pero 1 lang naman yan, no? So, multiply na natin or substitute na natin yung mga values. We now have C sub out, which is 75 ohms divided by quantity 1 plus 200,000. O, di ba? Ganyan. Yung Z sub out natin sa voltage follower, it is equal to 375 micro ohm. Aba, sobrang liit, ano? From 75, ang nangyari sa atin is naging 375 micro ohm. No? That's almost close to zero, which is very ideal sa mga buffer amplifiers. No? So, ganyan. Yan yung ating problem to further illustrate yung kagandahan ng mga voltage followers and the negative feedback. Okay? So, next. Now, we will discuss yung ating pangatlong configuration, which is the inverting amplifiers. No? Ito naman, kabaliktaran ng non-inverting amplifier, gumagamit tayo ng resistors ulit to ano to vary yung ating closed loop voltage gain. Okay? So, medyo babalikan lang natin yung diniscuss natin sa unang lesson, yung tinatawag nating virtual ground. Yan, di ba? So, dito sa kaso ng inverting amplifier, yung ating current dito sa ating input, nagiging equal yan sa current dun sa feedback current. So, nangyari dyan, current sa ating input equal yan sa current sa feedback. Okay? And because yung ating input current is also equal yan sa voltage input divided by the current input due to Ohm's law, yung ating namang current sa feedback, it is equal sa negative voltage output divided by the resistor or the feedback resistance. Yan. Therefore, yung ating Re-rearrange lang natin to. We now have voltage output over voltage input equal yan sa negative RF over RI. Diba? And of course, yung ratio ng ating voltage output sa voltage input, ang tawag natin dyan is the overall gain, and which is in fact equal yan sa ating closed loop voltage gain. So, ganyan lang naman siya, no? Okay? And using this, also by using this expression, we can now have yung formula ng ating voltage output equal yan sa negative R sub F over R sub I times yung ating V sub I. So negative, ibig sabihin yan, na-invert yung ating signal. Nagiging out of phase. Pag kinupute pa rin natin yung ating attenuation, equal pa rin naman yun sa R sub I. No? R sub I over R sub I plus R sub F. So lagi lang natin tatandaan yan. Okay. So in this case, meron kasi tayong value ng R sub I at R sub F. Kaya gagamitin natin itong formula na yan. So in terms sa mga input impedance and output, yung input impedance ng isang inverting amplifier is almost approximately equal sa ating input resistance. So ganun lang siya. Kung ano yung input resistance natin, yun na yung ating input impedance. Sa output impedance naman, gagamit pa rin tayo ng formula na ginamit natin doon sa non-inverting amplifier and sa voltage follower. So kailangan lang tandaan natin yung formula ng attenuation, no? Para masagutan natin maigi. So let us try to solve an example on this inverting amplifier. No? So given the op-amp configuration, meron tayo dyan, we have this inverting dahil yung input natin is pumasok sa inverting. We are to find the value of R sub F required to produce a closed loop voltage gain of negative 100. So this is actually a design problem. No, we are to find a specific value of resistance para ma-achieve natin yung isang voltage gain value. Maganda tong problem na to. So, ang alam lang natin sa mga formulas ng ating inverting amplifier is yung formula ng A sub C sub L or A sub CL. Yung ating closed loop voltage gain equal daw yan sa negative R sub F over R sub I. No. And we know, we actually have the value of R sub I equal yan sa 2.2 kilo ohms. And we also have the value of yung ating A sub L which is negative 100. Therefore, pwede natin makuha yung value ng R sub F. Rearranging the terms or the variables, R sub F will now be equal to negative A sub CL times R sub I. So substituting the values, we have negative times negative 100 times R sub I is 2.2 kilo ohms. Therefore, we need positive 220 kilo ohms, no? Para magawa natin tong ganitong circuit, no? So, ganun lang siya. Okay, next problem. Determine the input and output impedances of the amplifier in this figure. So we have another inverting amplifier in this circuit. Also, determine the closed loop voltage gain. So tatlo na yung pinapahanap sa atin dito. The op-amp has the following parameters. Input impedance is equal to 4 mega ohms. Output impedance is equal to 50 ohms. And the open loop voltage gain is equal to 50,000. So, daming pinahanap na. So, ang pinapahanap sa atin dyan is yung ating input impedance ng inverting amplifier, question mark. We want to find out the output ng inverting amplifier din na to. And we also would like to know yung ating closed loop. Closed loop voltage gain. Yan yun. So, ang given lang sa atin dyan, we have the input impedance equals sa 4 mega ohms. The output impedance equals sa 50 ohms. And the open loop voltage gain equals sa 50,000. So, ganyan, no? So, solution natin, unahin muna natin yung Z sub in. No? Ang formula ng Z sub in sa inverting amplifier, it is 1 plus open loop voltage gain times yung ating beta. Ay, sorry. Wala nga pala tayong ano dyan, no? Yung ating formula ng Z sub in, it is approximately equal na yan sa R sub I. Therefore, C sub in ng ating inverting amplifier, in this case, we have 4 mega ohms. No? Yan. Okay? So, C sub out naman ng ating inverting amplifier, equal yan sa, anong formula natin? Output impedance divided by quantity 1 plus open loop voltage gain times the attenuation. No? Where B is equal to R sub I divided by R sub I plus R sub F. Ganyan. No? Balikan natin yung formula ng B. Para sure lang tayo. Ito no. Para sure. Okay? So, substitute lang natin yung mga values na yan. We have R sub I, we have quantity 1 kilo ohm divided by 1 kilo ohm plus 100 kilo ohms. Therefore, yung ating B, yung ating attenuation, equal yan sa 0.001. No? Equal yan dyan. Gagamitin natin yan solve itong value na or to solve yung ating output impedance. So, we can now substitute the values in this particular formula. We now have C sub out is 50 ohms, di ba? Divided by 1 plus A sub O is actually 50,000 times the value of B, which is 0.001. The value of C sub out is 980. Sa calculator ko, 980 milliohms. So ito, C sub out natin is 980 milliohms. So from 50, naging 980 na lang siya, no? So, mapapababa pa rin natin to a desired value. And yung A sub open loop, pinahanap sa atin is, ano, di ba? A sub CL, sa isang inverting, ang formula niyan is negative R sub F over R sub I. R sub F over R sub I. It is equal to A sub CL equal to negative 100 kilo ohm divided by 1 kilo ohm. So, ilan yan? Yung ating closed loop voltage gain is now equal to negative 100. Okay? So, ayan. From open loop of 50,000, naging 100 na lang siya. So, ang effect talaga ng negative feedback sa ating op amps is reduced voltage gain. Okay? So, ayan. So, let me cut this part para pagandaan natin yung third part naman, no, ng ating lesson. Okay? So, mag-solve muna kayo ng isa or dalawang problem set before we go on to the next part of our lesson. Okay, maraming salamat. Sana meron kayong natutunan dito sa lesson na to.